Polar bears and polar cubs, it is that time. It is ideal gas law. It is what we will always call as Pvnrt. Now, I want to bring your attention to R, which is our constant, and it's on the back of your periodic table. We only give you one R value. There are tons of R values, at least a handful, that you can use. We kind of funnel you guys into liters, atmospheres, Kelvin, and mole. All of the other ones we've already known: temperature in Kelvin, volume, liters, pressure, atmosphere, and then N is number of moles. So we're going to run through one together. I'm going to have you try one, and then we'll show you another adaptation of Pvnrt. So originally it says, what is the pressure of a nitrogen sample if you have 0.50 moles? So we have N is equal to 0.500. You have V is equal to 10.0, and then T needs to be 298 Kelvin. So I got 298 Kelvin by adding 25 to 273. Our R value, okay, is 0.0821. And we're going to plug that in. So we have Pvnrt. So we're going to divide both sides by P. Oops, not by P, by V. We're going to get the same thing, but now we're going to get P is equal to nRT over V. So we're going to plug that in. You're going to have 0.500 times 0.0821 times 298 all over 10. So in your calculator, let's go ahead and do that. 0.5 times 0.0821 times 298 divided by 10. And I got a volume. V is equal to 1.22 liters. Oops, P. My apologies. It's the second time I've done that. That is, P is equal to that in atmospheres. Okay, and that is due to N2. All right, I'm going to have you guys do the second one. Keep in mind, you may need to do some conversions. All right, let's go through that in 5, 4, 3, 2, and 1. So now we have a N value of 0.00660 mole. We're trying to find volume. R is equal to 0.0821. You have temperature at 282 Kelvin, and you have pressure. We're going to take 89.4, and we're going to divide it by 101.325 in order to calculate that in ATMs. And that is at 0.882 ATM. So now we're solving for V. So it's going to be V is equal to nRT divided by P. We're going to go ahead and plug those in. So 0.00660, that's 0, times 0.0821 times 282 divided by our P value of 0.882. Plug it into your calculator. Multiply all the tops. Divide by our bottom. And I got our volume to be 1.73 liters H2. So that is a traditional Pvnrt. Those are two traditional Pvnrt questions. We're going to go ahead and show you a non-traditional Pvnrt. What it is N, which is moles, can equal the grams divided by the molar mass. This is usually work that you guys have done in like stoic or molar conversions, but you can plug it in. So we're going to run through this one together. So it's an unknown gas. We have grams of it at 0.116. We have a volume. Now it's got to be in liters, so you're going to move this decimal place 3 spaces over, giving us 0.025 liters. Temperature needs to be in Kelvin, so we're going to add 273 plus 127, giving us 400 Kelvin. And then pressure, again, we're going to take that 155.3 and divide it by that 101.325 to give us it in ATMs. That's going to give us 1.533 ATM. So now it's kind of plugging it in. We're trying to find the molar mass that's in the bottom. So the original would look like this. PV equals GRT over MM. Now, if you're solving for MM, that is going to change spots with PV. They're just going to switch spots, giving you MM equals GRT over PV. So then we're going to plug it in. Remember, your R value is still 0.0821. So we have 0.116 times 0.0821 times 400 all over 1.533 and 0.025. So let's total that out. I got 0.116 times 0.0821 times 400 divided by 1.533 and divide that also by 0.025. That's going to give me a gram molar mass of 99.4 grams per mole. Now, since we don't know what gas it is, that's how we'll have to leave it. All right. That has been the ideal gas law. Let me know if you have any questions.